Unit 2, and now we will be going for WAN connectivity protocols, right? We have two protocols, that is they are PPP and HDLC protocols. So these protocols we will be looking into details. So before that, let's go in the revision of what is this WAN topology. So WAN is a wide area network, and it is used for connecting computers and cover a wide geographical area. That is the important part. So from the image also you can see that it covers a wide geographic area. You can see the internet, then satellite. Now it is connected with some space. Gateway servers are there. Then we have cellular phones also. Then we have local Wi-Fi areas also, which are connected through this WAN. Correct. So what does it mean is a WAN is going to cover a wide geographic area, and which often contains a smaller networks like LANs, MANs, and etc. Right. So in a WAN, there are few technologies which are used. Correct. These are the packet switching technology and circuit switching technology. Now let's see again in detail. Like there are different types of a WAN which are existing today. It is up to us, like what is the right version of the WAN which we are supposed to use. Before going to the PPP and HDLC protocol, it is necessary for us to know why we are using this protocol and where are we actually using this protocol. Correct. As we are studying these two protocols with a DLL layer, so it is sure that these two protocols are used at a second layer of TCP/IP model or OSI model, and that is my data link layer. Correct. But what is the reason behind using these protocols and where are they used? So these particular protocols are supporting WAN connectivity. Correct. Now this WAN connectivity, or we have this three types of the connections in the WAN. So first type of a connection is a leased lines. Then we have a circuit switching, and then we have a packet switching. I hope you are able to see this on the screen, that leased line, circuit switching, and packet switching. Good. Now these leased lines are dedicated point-to-point connection. Correct. Where a permanent communication path exists between a customer premise equipment on one side and a CPE at a remote side communicating through a data communicating equipment. So these are few terms of this or terminologies in this area. Correct. So where these lines are uh, where these lease lines are installed, these lease lines are a permanent communication. Correct. So it is a path between customer premise equipment, that is my CPE from one side, and then the CPE at a remote site. Correct. So it is communicating through a data communication equipment, right? So within a provider side. So synchronous serial lines are used for this connection, and the most frequent protocols observed in these lines are HDLC and PPP protocols, which we will be studying now. So these HDLC protocols are high level data link control protocol, and we have the point to point protocol. Correct. So now again what I want to emphasize on is this WAN connection types, right? That is my wireless connection types. We have three types for the WAN connectivity. These are leased lines, circuit switching, and packet switching. So leased lines are using HDLC and PPP protocol. We have some different protocols at circuit switching and packet switching. So at leased lines, what is the conclusion? At leased lines, we have HDLC and PPP protocols. So these protocols which are given in our syllabus are used in leased line. For circuit switching, we can see over here, we use ISDN, that is Integrated Services Digital Network Protocol. And for packet switching, we have a frame relay protocol, correct? So depending upon the type of this WAN connection, the protocols are used. Mainly these WAN connections, when they are through the point to point dedicated connection, our HDLC and PPP protocol is used. I hope this is clear with all of you that where we are using HDLC and PPP protocols. Now let's move ahead and let's look into these leased lines wireless LAN wide area network in a detail. Okay, so as I already told you that this particular leased lines, right? How they are used? They are used as a dedicated lines, and one end is connected to customer premise equipment and another end is connected to the remote side CPE, and they are communicating through a data communication equipment. Fine. Now let's look into this point-to-point protocol. Fine. So till now what we have seen? So we have seen that this particular point-to-point protocols and HDLC protocol is used at a second layer of the second layer of a TCP/IP model. Correct. Now, these particular protocols are used when we have the WAN connectivity, that is a wide area network connectivity. And in a wide area network connectivity, also we have a different types. We have a types of a leased lines, we have a type of a circuit switching, we have a type of a packet switching. Out of this, when we use leased lines, then we go for this HDLC or PPP protocols. Fine. So I hope the background of this PPP and HDLC protocol is clear with all of you. Now let's look into one of it, like the point-to-point protocol. Okay, where is this point-to-point protocol is used? So point-to-point protocol is the communication protocol of a data link layer that is used to transmit a multi-protocol data between two directly connected computers. Correct. It is a byte-oriented protocol. Fine. That is widely used in a broadband communication, having a heavy loads and a high speeds. Fine. So there are few services which are provided by PPP. So these are the services are defining the frame format of a data to be transmitted, defining the procedure of establishing link between 2 points and exchange of a data, stating the method of encapsulation of a network layer data in a frame, stating authentication rules of the communication devices, providing address for the network communication, provide connection over a multiple links. So these are few services which are provided by PPP protocol. Now let's look at the PPP frame format. At the top, please look at this frame format. So what we have at a PPP frame, we have a flag, then we have a address, control, then protocol, and then payload. Payload is a data. So let's look into detail about this all fields. As we have already known that PPP protocol is a byte-oriented protocol. Correct? So the fields are, the first field is a flag which is of 1 byte that marks the beginning and the end of the frame. This bit pattern of the flag is 0, then 111, 0. So that particular flag we are supposed to append at the start and end of the frame, which shows the start and end of your starting and ending of the frame. Correct? Then the address. Here we are supposed to give the address of the destination. This is also 1 byte field and it is set to all ones in the case of broadcasting the particular frame. So whenever we are going for broadcasting the frame, we set all these numbers as 1. Then we have a control. So that is again a 1 byte frame, and this particular is having the constant value. This value is never changed, and that value is the 2 times so 1 1 1 and then all remaining 0. Correct. Now we have the protocol field. This is 1 or 2 bytes that defines a type of a data contained in the payload field. Fine. So that is my protocol field, right? And then payload. So what is payload? Payload, it carries the data from the network layer. The maximum length of the payload field is 1500 bytes. However, this may be negotiated between the endpoints of the communication, that is between the sender and receiver. And then lastly, we have this FCS field. Now this FCS is a frame check sequence, right? And it is used for the error detection. It is either a 2 byte or a 4 byte field. And the standard code used is a CRC. So we have seen the CRC in this unit. So that particular CRC code is appended in this FCS and it is sent with a frame. Fine. So these are the different fields of PPP frame. Now, why we call this PPP as a byte oriented, a byte stuffing? Because byte stuffing is used in a PPP payload field whenever the flag sequence appears in the message. so that the receiver does not consider it as the end of the frame, right? The escape byte and 0 3 triple times 101 is stuffed before every byte that contains the same byte as a flag or the escape byte. Right? So have you understood what is the use of this byte stuffing? So suppose in a data or in a payload, we are having the data which is having the sequence as 0, 6 times 1 and 0. And that is again flag also. So to differentiate between the flag and data itself, we stuff a byte. And what is that byte which is stuffed? The byte is 0, 5 times 1, 0, 1. So this particular byte is stuffed if the escape character or the flag byte appears in the data. Fine. So this was about the PPP frame. Now we'll see the components of the PPP protocol. So the three components are there. The first component is the encapsulation component. Then we have the link control protocol and the authentication protocol and network control protocols. Correct. So what we have over here is the encapsulation component encapsulates the datagram so that it can be transmitted over a specified physical layer. Then we have the link control protocol. It is responsible for establishing, configuring, testing, maintaining, and terminating the links for the transmission. It also imparts the negotiation for setup of options and use of features by two endpoints of the link. And then we have these authentication protocols for authenticating endpoint services. Okay. Now move towards the HDLC protocol, that is a high level data link protocol. Now as I have already said that PPP protocol is my byte oriented protocol, correct? This HDLC protocol is a bit oriented protocol. Please remember these two things very well, because in exam sometimes you get a question as explain the bit oriented protocol of data link layer. Then you need to know which is this bit oriented protocol. So this HDLC protocol is my bit oriented protocol. Right? Let's look into details. So there are few transfer modes which are used in the HDLC. Right? These transfer modes are used in the point-to-point communication and multi-point communication. What do you mean by point-to-point communication? So in a point-to-point communication, we have one primary station, one secondary station, and only these two stations communicate with each other. Right? That is my point-to-point communication. In a multi-point communication, we have one single primary station, but there will be multiple secondary stations which can send responses at a time. So that is my multi-point communication. So I hope you understood the point-to-point communication, multi-point communication. So in a point-to-point communication, a single primary and single secondary station is there, and they communicate with each other. In multi-point communication, we have a single primary station and multiple secondary station. So this multiple secondary station can send responses at a time. Right? Now let's look at this transfer modes. So there are two types of a transfer modes in a HDLC. These are normal response mode and asynchronous balance mode. So let's look at this normal response mode. Here, two types of stations are there. A primary station that sends the commands and a secondary station that can respond to receive commands. It is used for both point-to-point and multi-point communication. Okay, so normal response mode kaisa hai? Which is a normal response mode where a command is sent by a primary station and response is sent by a secondary station. So this particular type is used in both point-to-point and multi-point communication. Now let's look at the another mode of a transfer, which is the asynchronous balance mode of HDLC. Now in this asynchronous balance mode of HDLC, the configuration is balanced. What does it mean? It means that each station can both send commands and respond to commands. Right? So here there is no concept of primary and secondary. All the stations are having equal privileges, equal rights. They behave equally. Right? So in this case, each station can send a command as well as each station can respond to the commands also. So this is only possible in point-to-point communication. So this asynchronous balance mode is applicable only in point-to-point communication. So have you understood? I hope you have understood the different transfer modes of HDLC. So there are two transfer modes of HDLC. The first one is a normal response mode and the second one is asynchronous balance mode. Okay. Now look at the frame format of HDLC. So here again look at the screen. We have the flag, address, control, payload, FCS, and again we have a flag field. Correct. Now HDLC is a bit oriented protocol where each frame contains up to 6 fields. Correct. The fields are flag. The flag is a 8-bit sequence that marks the beginning and the end of the frame. So the pattern of the flag is 0, 6 times 1s and 0. Right. It is a fixed byte which is used as a flag. Then we have an address. Now what does this address contains? This address contains the address of a receiver. If the frame is sent by the primary station, it contains the address of the secondary station. Right? And if frame is sent by the secondary station, it contains the address of the primary station. So the address field may be from 1 byte to several bytes. So this is about my address field. Then I have a control field. So this particular contains the control information about the flow and error control. Fine. So the control bit have a control over the flow and error. Then we have a payload. Payload is the data which we carried from the network layer, and its length is variable depending upon the negotiation between the sender and receiver. And lastly, we have this FCS, that is a frame check sequence. It is used for the error correction, and again over here also we use CRC in the FCS. So CRC code is used in HDLC frame for the error detection. Understood all of you? And lastly, again we have a flag to say to show the end of the HDLC frame. Right? So this is all about the PPP and HDLC protocol. Now let's look at the types of the different HDLC frames. Right? So there are different types. The first type is I frame, then we have a S frame, and we have a U frame. Correct. Now what is this I frame? I stands for information. So I frame is an information frame. Carry user data from network layer. They also include flow and error control information that is piggybacked on a user data. The first bit of a control field of I frame is 0. So please remember, how does this different frames are differentiated? They are differentiated by the field control. As we have seen over here also, HDLC frame में control करके field है, correct? अब ये control field है, ये control field का जो data है, उस data के base पे we differentiate or we categorize the HDLC frame. So whenever the control field का first bit is 0, it means that it is my information frame and it carries the data of the upper layer, correct? The next is my supervisory frame, that is my S frame. So whenever the control field data is 1, 0, so first 2 bits of the control field is 1, 0, then it is my supervisory frame. Right? So when it is used for the flow and error control when piggybacking is not required. Fine. So that is where my S field is. A supervisory frames are used. And then I have the unnumbered frames. So these unnumbered frames are used for carrying the miscellaneous functions like link management. So it may contain an information field if required. So how to identify these unnumbered frames? So whenever first 2 bits of the control field are 1, 1, then it is my U frame, that is my unnumbered frame. Right? So these are the 3 types of HDLC frames: I frame, S frame, and U frame. Right? So it's all about the HDLC and PPP protocol. So again, let me have a quick revision. We have WAN, that is my wide area network. So in wide area network, there are 3 types of connections. These 3 types of connections are leased lines, circuit switching, and packet switching. So whenever I used leased line connection, over there, the protocols which are used for this communication at DLL layer is HDLC and PPP protocols. If I go for circuit switching, I will use ISDN protocol, and for packet switching, we use frame relays. Okay? So for the leased lines, this PPP and HDLC protocols are used. This PPP is a byte-oriented protocol. And this is all about the frame structure of PPP. It consists of flag, address, control, protocol, payload, FCS, and flag. Fine. We have some components of PPP. They are encapsulation component, link control protocol, and then network control protocol, authentication protocol. Correct? And then we go for the HDLC protocol. Now this HDLC is a bit oriented protocol. In this, we have two transfer modes, that is normal response mode and asynchronous balanced mode. The frame is consisting of flag, address, control, payload, FCS, and again at the end, to show the end of the frame, we have a flag. The different types of HDLC frames are I frame, S frame, and U frame. Fine. So even we have seen this frame. Now let's look at the differences between this HDLC and PPP protocol. Fine. So what is the full form of it? It is a high level data link layer protocol. PPP is a point-to-point protocol. HDLC is a bit oriented. PPP is a byte oriented protocol. HDLC used in only synchronous media. PPP can be used in synchronous as well as asynchronous media. No provision of authentication in HDLC. PPP supports authentication. Dynamic addressing is not offered in HDLC, but it is offered in PPP. HDLC is implemented in point-to-point and multi-point configuration both. PPP is only available for point-to-point configuration. HDLC cannot be operated with non-Cisco devices, so it doesn't have the compatibility with the other protocols. Now this PPP is interoperable with non-Cisco devices also. So these are the major differences between HDLC and PPP protocols. So this is all about WAN connectivity protocols as HDLC and PPP.